In 2006, 80 deer were introduced into a wildlife refuge. By 2012, the population has grown to 180 deer. The population was growing exponentially. Write an algebraic function n sub t representing the population n of deer over time. Okay, a few things that we need to know. An algebraic or an exponential function looks something like this. F of x equals ab to the x, where this is the initial. So what we're going to have to do here, because they want us to use n sub t, I'm going to replace the y value, f of x, with n sub t. And because this x, on the second one, the one we're going to do now, should be used with t. So that's what we're going to plug into. Well, what do we know? Well, initially, which is at 0, we had 80 deer. Time, so from 2006 to 2012, that's 6 years later, we have a population of 180 deer. So what our goal is we've got to find the A and we've got to find the B. Well, what do we already know? We already know the initial, which is A. So we know n sub t equals 80b to the t. So what we're going to try to figure out right now is we're going to figure out how the heck we get this b value, and here's how we do it. I'm going to take a point which is x, comma y, and in this case t, n sub t. So I'm going to replace the n sub t with 180 equals 80. B, I'm going to replace the t with the value of 6. So I use this point right here. So my next step is to divide both sides by 80. When I do that, I get 2.25 equals b squared. So my next step here is going to be not b squared, b to the 6th. So I'm going to take the 6th root of both sides. When I do that, I get b is approximately 1.14. So now I can write an equation. An equation goes back to looking like this, remember? Or even better, this. So n sub t equals 80, 1.14 to the t. Now you cannot multiply 80 times 1.14 because we have to do order of operations. When I plug in for example, 0 for t, I would say 1.14 to the 0 power times 80, and that will give me this 80.